everyone. We are getting an exclusive tour of the West Australian radar site with one of the best at LeoLabs. Craig, over to you.
Hey everybody, how are you? Welcome to the West Australian Space Radar. This is one of the 4 structures that are part of our radar site here. We have 2 different radar systems operating independently. One is looking off to the north, another is looking off to the south, where we have these array of electronics, thousands of antenna elements on every site that are working at an S-band frequencies, and so we have to get them down to very tight tolerances. You can see all of our electronics are in this one-dimensional array here. These white boxes have power amplifiers, antennas, phasing control and things of that nature. And then these different reflector panels that are modularized in order to make a parabolic shape. We manufacture all of these structures in the United States, ship them all over the world so that we can mass produce these things for space sustainability and space safety. This site in Western Australia really benefits our Southern Hemisphere coverage. We're building out a number of sites over the next year or 2 in the Southern Hemisphere in order to really build up that coverage of what's happening on this side of the world.
Awesome. Can I ask some dumb questions
Okay,
for the people?
Okay, I'll try to answer them, yeah.
What's the significance of the actual shape of the radar, the parabolic shape you just mentioned?
Yeah, the significance is that it focuses all of the energy that is transmitted out of the antennas. It focuses it up into a region of space where we can track satellites, debris fragments, and rocket bodies. And then all of a little bit of that radio signal bounces off of that object, comes back down to Earth, and then this parabolic shape focuses that little energy back onto our antenna elements where we can then process that data and try to find that object in the noise.
So this is actually our 6th radar site.
Correct.
We have 10 radars now. Can you talk a little bit more about how they all kind of work in collaboration with each other in terms of the data it's getting and the coverage and things like that?
Certainly, that's a great question. So we collect data from, we're on 4 continents at this point, I believe, and all of that data is fed up into the cloud where we do orbit determination and try to discern, okay, when is an object going to then pass over our next site? We schedule that event and then tee up one of these radars to look for that object. We see it, we do some on-site data processing. We can even see the same object and track it in both radars as it flies through one field of view and then into the other. And so we can get some really precise orbit determination from that.
In terms of like the actual materials that you pick for the radar and the color, is that really significant?
Certainly, yeah. What we're really looking for is durability. These systems are designed to last for 20, 25 years. And so we hot dip galvanize all of the steel. We mass produce this stuff so that we can deploy it to tropical regions, islands, cold environments, hot environments. And so hot dip galvanized steel takes very long to corrode and things like this. And so this can be here with a very long lifetime to first maintenance. Otherwise, we have other painted steel materials. We have an aluminum surface that is very good at actually reflecting the RF signals. And then we use myriad components and materials up in the electronics that can sustain high temperatures, low temperatures, and work in a lot of different environments. And that's what really allows us to deploy these systems globally and quickly.
Yeah, and a question about so we do have different sites, as we just mentioned. What sort of goes in at a high level at determining what the best site is?
At this point, we're really trying to grow our global coverage. And so if we have just a couple of sites in the Americas, we want to find a site in Europe. We want to find a site in Oceania. We came to New Zealand a couple of years ago. Now we're here in Perth, or down in Collie in Western Australia. And so we're really trying to grow that coverage. Our hope is that we have a radar in Africa sometime next year. We are hoping to deploy radar in South America, get a couple of radars into Asia, and really start growing that geographic diversity. That's really the key, so that we can get very high revisit rates on all of these objects as they're passing over different parts of the globe.
Can you talk a bit about the revisit rates? I think most people probably won't know what that means.
Oh, sorry. Yeah, that's
another dumb question.
No, it's totally fair. Yeah, it's just jargon for getting to see the object. Every time the object passes over a radar site, we get one blip of it, and then we have to project days in advance where we think that object is going to be. So the more frequently we can actually see it, we don't need to make such long predictions. Long predictions end up having error bars that grow because of solar weather. The object could be maneuvering, things of this nature. So if we could see the object more frequently, we can have really good high precision on where the object might be at any given time. That's what I mean by it.
Awesome.
Yeah.
What is S-band technology?
No, that's a dumb question. Yeah.
I appreciate that.
Yeah. S-band technology, so there are radio waves at many different frequencies. It's a spectrum of frequencies. We have a site in Texas that uses UHF, so it's a certain frequency that can see objects 10 centimeters and larger, so the size of a basketball or something to that effect. We was starting to design and deploy these S-band radar sites because we're looking for smaller objects, smaller than 10 centimeters, smaller than what anybody currently has a catalog of. And so S-band can potentially see objects as small as the size of a quarter, or some sort of coin currency, wherever you may be. But and so there might be 250,000 of those objects floating around that can destroy a satellite, that can damage satellites, damage human space flight and things like that. And so we're really trying to track all of those objects safely. So
fantastic.
So S-band, we chose that for that reason.
Awesome. Any last facts people should know about this site or radars in general?
Radars in general, we're just trekking all over the world trying to find places to put these things: hail, snow, wildfires, heat waves, earthquakes, hurricanes. We're just trying to get it out there so that we can really help bring superior information to this new domain.
Fantastic. Thank you so much, Craig Trumbull, Director of our radar deployment group, and always does a great job. Always traveling the world.
Oh my God, thank you very much. It was fun.
He's always everywhere, so we'll see you guys later. Thanks so much. Bye.